Hey, 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 and welcome back to the Awakening Spaces podcast. Today, I had the pleasure of interviewing and chatting with Emily Mottram, who is one of the principal architects of Mottram and Mains in Maine. And I first was introduced to Emily when I was taking an advanced building science course at the Construction Instruction Institute. Her and Nikki Kruger were co-teaching a class on the building envelope, and they were just so amazing. I absolutely loved them, and they were just really bright lights in the industry, welcoming all of us in with open arms. It was a women's in construction specific event, and they were just really there to empower women in construction. And so I got their emails and became friends with both Emily and Nikki, and they're just doing such wonderful work. And Emily, I was so excited to chat with her. I didn't know what we were going to chat about today because there was just so many things that we could go deep on. Emily is a wealth of knowledge. Truly, I was like, where do I want to pick her brain? There's so many things. I hopefully will have her back on the podcast to go to even deeper on certain subjects because there's just so much that she could chat about in this space. And she's worked on projects where she's had clients who have had chemical sensitivities, and they've done really unique things to support their clients. So I'm really excited for you to listen to this one. We touch on a lot of really important topics and things that anyone who is building a house, renovating a house will enjoy. We talk about spray foam. We talk about paint. We talk about healthy materials and some of the things that have worked on her projects and the priorities of things to focus on with health. So I think you're really going to like this episode. I also want to mention that Emily wears a ton of different hats. She has her own podcast, and she's also a co-host on the BS and Beer show. And she's also just out and about in the world teaching and lecturing and giving presentations at different conferences and events. So you always have an opportunity to learn from Emily. She is amazing. So anyways, without further ado, let's dive in. Welcome to the podcast, Emily.
Thanks for having me. I'm so excited.
I am so excited to chat with you. Before we hit start here, me and Emily were just talking about it. There's so many things, so much knowledge that you have just in the healthy building space, in the building science space, and just how to help people create a pretty good house. So I would love for you just to start, who are you? How did you get into all of this? What started your trajectory to become an architect? What was your path?
I am a residential architect based in Maine. That's where my primary practice is. This is where my husband is from. I grew up in Pennsylvania. I went to apparently a really good high school. I didn't know, but I took drafting classes in high school, and I had this amazing drafting teacher who absolutely loved me. There was another Emily in the class. We were Emily squared. We were his favorite students. And one day he said, architecture school is really hard. And I said, sign me up. That sounds like what I want to do. So I already knew I liked drafting. My grandfather was a contractor, although heavy bridge building contractor, so not necessarily residential. For my whole high school career, we did Habitat for Humanity stuff in the summer. So I got to spend some time on people's houses, just helping out. I think the first year I painted because I was a 14-year-old kid. So I painted on someone's porch roof, and I don't really like heights. And so I was never again. I'm not painting. Give me a tool belt. I can construct things. Forget this. One year I replaced a whole bathroom with another guy. It was in Savannah, Georgia. It was two of us in an 8x8 bathroom with the window that didn't open, and it was so hot. But anyway, so I had some construction experience. My dad is actually a dairy farmer, so I came from a farming community. And
Wow.
So I kind of grew up farm to table, and I didn't know that was a thing because that was just our way of life. We had an acre of garden. We planted things. We harvested it. We froze vegetables every year. We canned things. I did that in our garden, in my grandmother's garden, and my dad's sister is a produce farmer. So if we didn't grow it, she grew it. So that was how I grew up. And so I think some part of me has always been in this environmental world where you use everything that you have, and there's this purpose, and you can grow things. Something that goes really along with building science and healthy environments is growing up in this farming community. So my drafting teacher said, architecture school is really hard. So I was sign me up. I'm going to do that. Let's go. And I went to Penn State for architecture school and had 5 amazing years. Architecture school is 5 years, and got to study abroad in Rome, which was fantastic. And then got a job in Washington, D.C. And I kind of knew I wanted to work in the residential space, moved to Washington, D.C. My husband and I lived in DC for 2 years, and we were just doing these massively huge projects. They were beautiful. It was just a straight residential firm. That was all they did. But to me, it felt like they were missing something. Were they gorgeous? Absolutely. So I convinced my boss, I worked in a satellite office in Virginia part of the time, and I convinced my boss to take the lead exam with me in 2006. And it was like one of the only certifications that was well known. It was still lead for new construction. So it wasn't even necessarily about residential at the time. And I was like, we got to do this. Like, this is important. And it really is so funny to me because we only stayed in DC for 2 years. We were like, we don't know our neighbors. We're young and not making a ton of money. So we should live closer to one side of our family or the other. The joke is we flipped a coin. My husband won. We moved to Maine. That's mostly true. And I have not regretted it ever. We moved from Washington, D.C. to Maine at the time, but I just ran into the gentleman that I worked for in D.C. maybe like a year ago, and he called me and he said, hey, Emily, I'm having trouble with these like healthy building materials. I have somebody that has this stuff. Can you help me with the building science and building material stuff? Because I know that you're an expert. I was like, so strange to me to go like role reversal. I would say he taught me so much about how to be a good designer and a good architect. And now we're going the opposite direction and we're talking like, hey, let me help you with the things that then I became passionate about. So then when we moved to Maine, I knew I wanted to work for an architect that was doing more in that space. It was 2007. The market was still pretty good at the time. I had my pick. I interviewed with 5 different architects. I picked one that had just built the first lead house in Maine. I thought, this is it. This is great. But at the time, there was still a lot of let me design the house and then try to make it more efficient, which felt very backwards to me. And I thought there has to be more. And then anybody who's been in the industry for long enough knows that 2008 rolled around and like 2008, 2009 saga was like gainfully unemployed to be an architect. Just totally different scenario. That was kind of when I said, all right, I'm now a licensed architect. I have achieved this thing because it's 5 or 6 years of architecture school. It's 3 years equivalency worth of internship afterwards. Then you can sit for the registration exams to be an architect. At the time in 2009 when I did it, there were 9 exams. I think there are only 7 now. I think they consolidated a little bit, but there are 7 exams. The structures exam is like 6 hours long. Like they are intense. And so when you get to that point, you've now probably spent 9 to 10 years of your life in the architecture world. When you get licensed, you finally go, I can do something else now. Or I can be an architect, and what does that mean to me? And that's probably the point at which I really jumped deeper into the building science because there wasn't a lot of architecture going on. And I kind of looked at Maine and said, what does Maine need? What do we do? And that was when there was ARA money coming into the state for people to improve their homes. And so I got the opportunity to learn so much more about how houses are constructed, how we can improve them, how we can make them better for the occupants. And that was when I think I really got deep into the building science and started moving towards where I am now. I think it's always been part of the journey, but that was a very long explanation of how I got to here.
Yeah, but it all ties in too. It's like your lifestyle nurtured this path just for caring for the environment and learning how to homestead, and is somewhat of what I'm hearing too. And it kind of makes sense when you're trying to make things better in one way, like eventually you get to building science, because that's what it is. Building science isn't like this one thing. It's like constantly just learning, how did we fail on this one? How do we improve it the next one?
Yeah.
Who were some of the first people you were learning from, or like what that path look like for you at the beginning of like diving into building science?
I'm so glad that you brought this up because I worked for a phenomenal woman. Shout out to Cheryl Schattenberg, who is still doing training. I actually sent some of my team to do like a whole day of training with her because I followed this woman around for 3 months before I was allowed to do anything on my own. Basically, we would go out and we would evaluate people's homes. And I think this is the part that gets really missed in the construction industry is when you're trained that way, the first thing that you do is health and safety, right?
Right.
We did not do anything or make plans for anybody in their houses if they had water issues, if they had unvented space heaters in their houses. There was so many things that we did that were health and safety issues before we could even, everyone's like, what's the low hanging fruit? How do I improve this? What do I do? And it's like, whoa, if we make any improvements, we're going to make a problem that's not great significantly worse. And so I
Mm-hmm.
learned so much about, the building science. And I often like to refer to it as building biology, right? Like if we want to get better in our bodies, we start to understand biology. How do our bodies work? How does all this stuff? Well, it's the same with houses. Houses are a system. They're this whole biological component, and lots of things can really affect it. And in the construction industry, we know how to follow the code, right? So we maybe are getting better at hopefully it's not going to fall down or all this stuff. But I love when a fellow Denver friend talks about the building code, Glenn Mathewson. He said that the code is really a recipe book. Right? You're meant to be able to use a bunch of different recipes. But sometimes I think people don't realize that the recipe is calling for sugar and you put salt in it because it looks the same, but it's not the same thing. And that makes a bad recipe, right? So just because this part of the code says you can do this one thing and doesn't call out a material doesn't mean you can use this other material to do that without understanding everything that's in the recipe. Or like I always say with walls, like with everything that's in the sandwich. There's things that are in all of those. And so when I first started, it was considered gainfully unemployed to be an architect in the 2009 era. I started working with Cheryl. We started doing energy audits for occupants. I followed her around for 3 months before I was allowed to do anything. We first started with just the state energy auditor. Then we did Building Performance Institute, energy analyst, I think. Then I did HERS rating. So we just kept going up in certifications to increase our knowledge, because the one thing that is really fantastic about a lot of these certification programs are they're not all the same. So each one will teach you something that you didn't know before. And so when we got to some of the higher up ones, we started looking at combustion safety. If we do the low hanging fruit where we caulk around the windows and we make it airtight, which is fantastic. Absolutely want to do that. Want to make things super tight. We can create backdrafting with these combustion appliances. We can create moisture issues that we didn't have, or the entire state of Maine is a radon state. We can trap radon inside, which is related to lots of other health issues. And so you can't just do one thing without thinking about how that might impact other things. And then the more you learn, the farther down the rabbit hole you go. What's been really important for me is knowing that the more I know, the less I realize I know.
Yeah.
Which is,
I've said that on so many podcast episodes. That's exactly, I'm like, the more I learn, the more I realize I don't know.
Yeah. So I want to always be a consummate learner. I want to always be trying to better understand everything. Our friend Kyle did an episode on the BS and Beer show recently where he did indoor environmental quality. Right? It's not only about air quality anymore. We need to talk about other things aside from that.
Yeah.
Or, a lot of building standards don't talk about materials. They're like, for a while, and Passive House is really getting better with different things. But at first, you could build a Yeti cooler in the woods. And now we're like, oh, actually, density and maybe not living so far out of town. And also all these foams that we're using and, et cetera, et cetera. Maybe we should be considering these materials and how they work and what they do. And so every rabbit hole is just a new way to learn. When I took the Passive House class in 2016, the instructor for the building science portion was like, why are you here? Because when he didn't know the answer to a question, he would ask me and I would answer it. And I'm like, you're going to teach me something I don't know. I don't know what it is yet, but you're going to. And I did. I learned a ton of stuff in that class. So it was fantastic.
I love that. Oh my gosh. So you've done so many certifications already. Do you feel like you've done everything you've wanted to do? Or is what's your next thing? What's Emily's next class and course? I'm curious.
I mean, I don't even know what the next class or course is, but the answer is no, I haven't done all of the things that I want to do. One, because it continues to change and evolve as materials change and evolve. And as things I went to a really phenomenal, you would have loved this. Our friend Alan at Geologic does a Scale Up Carbon Down event every year. It's a one-day event. He usually has a couple of speakers, and he had 2 MIT professors come in and talk about some of the research they're doing doing? And I'm like, tell me more. I need to know more. Like the stuff that people are doing in research schools that I haven't even contemplated yet, right? Like I don't know what I don't know yet. And as we learn more about healthy building materials and all of that, people will start to develop standards around that, even in the healthcare. So like Caroline Blazowski does the Healthy Home Summit every year. And man, I tune in and watch those videos. And I'm like listening to the healthcare professors or practitioners or people who do research talk about their findings and then being able to say, wait, how do I apply that to the building environment? Because I feel like the built environment has a big impact on this. Someone posted, used to be 90, now I think it's 93% of our time is spent indoors now. I know you're in Colorado, your wildfire season has started even earlier. So even if you wanted to hang out outside isn't necessarily the healthiest place for you to hang out.
Yeah.
So many things.
Yeah. This always brings me back, looking back on my life. I worked as an interior designer at a really large firm. We did healthcare. We did a cancer walk-in clinic, but like in a bigger hospital. As the interior designers, we wanted everything to feel very homey and warm and like you were just walking into your living room. And I remember we were putting vinyl wall coverings on the inside face of these buildings. And that was never getting communicated or coordinated with the architects from a building science point of view. And looking back, this was years ago now, but I'm just like, holy crap, there's so many things that we don't realize we're doing that are inadvertently causing harm to a building. And we think we're doing the right thing because we want it to feel a certain way. It just made me think of that a little bit, that there's just always, you don't know what you don't know. But then when you learn, you're like, oh, wow, like, I never want to make that mistake again.
And I appreciate what you are doing now because you're sharing that knowledge. Because the reality is there's still a lot of people who are putting vinyl wallpaper on the inside surface of commercial buildings without having any idea what that is actually doing to the space. Because what happens as part of it, it always comes down to budget, right? And maybe you originally had like a nice grass seed wallpaper, breathable, wasn't vinyl. And it's like, okay, we can't afford that. But here's this vinyl version that looks like this other thing and it's half the cost. And we're going to put that in. And it's like, yes, it's half the cost of the upfront cost, but its long-term effect is massive. Right? And I had a builder once say to me, there's never enough money to do it right the first time, but there's always enough money for us to come back and fix it. I think it was two Harvard professors wrote a book called Healthy Buildings, and they talked about a Legionella outbreak in the hospital. And it's actually cheaper for the hospital to let their insurance handle it than to actually solve the problem. Like, how have we gotten to that place in our built world and our built environment that people's lives are expendable because it's too expensive to fix it from the operating budget, and you already have to pay for insurance, so the insurance will just take care of it after something has happened. Like, that to me is scary.
That is so scary. Oh my gosh. Yeah. Wow. That is wild. These are healing spaces too. And there is really so much thought that goes on into it. And I feel like there's more and more. I don't know if you're seeing this, but I feel like there's so many levels to like what a healthy space is or a healthy home is. And I feel like oftentimes people think, well, okay, yeah, just build the building, let the building be what it is. We don't really care what is going on behind the walls, but like if it has a red light panel and it has a sauna room and it has a gym, now it's a healthy space. It's just like, it goes so much further and deeper than that. And so you've done so many trainings, so many certifications. What are your priorities? And maybe this kind of goes into like, what is a pretty good house? Like what is a healthy home to you? What does that mean to you?
That's actually a really great question because the priorities can be really different. One, depending on where you're practicing, depending on the occupants of the space, depending on the budget that is available to you. So we had a client reach out to us. They lived over a bus station in Boston for 10 years. They ended up with multiple chemical sensitivities. Their goal, they came to Maine to find a piece of property. They stood on all of their properties and counted the number of cars that drove by because they just had so much reaction to years of exposure to petroleum. They picked a piece of property and it was like 1.5 cars every hour or something like that. So it was not a lot of vehicle traffic. And we lucked out because they didn't have a significant budget. They didn't have the I'm going to build a living building challenge house with millions of dollars kind of budget. They had a very limited budget and they were willing to live with 1,100 square feet. It's tiny. The spaces are tiny, but we had to take as much petroleum out of this building as physically possible, which is really hard with today's building materials, and then ventilate for whatever we couldn't get rid of. And it was a great learning experience. I actually met a phenomenal builder, which building this house anywhere else, so they lucked out because they landed in this neighborhood with this builder who's a 5th generation builder who doesn't build with plywood. They just use board sheathing. Fantastic. That's wonderful. It's kind of an old school way of building, but it's more expensive than when you ask your builders who build with plywood normally to do it. But that's just how they do it. And it was cost effective. It was like right place, right time. It was great. That house smelled like a Christmas tree when you walked into it. It was amazing. Like, it was absolutely great. So then we moved on to our second house with somebody who had a massive mold exposure. So she's like, I want to be really cognizant of the materials that we put in here. I want to be looking for the Title 24 compliance stuff. I want it to be low VOCs, whatever. And we're like, great, we just did this house. We've learned so many things. We're going to do these things. Moves into her house and literally cannot live in this house. And we're like, I don't know what's going on. Her husband was fine, but she was having a massive reaction to this house. So she moved into one of our other houses that had been done for like a year or more and was fine there. So we knew it was probably not most of our building practices. Turns out she is allergic to pine, which is the thing that we used to get rid of chemical sensitivities for our last house. So sometimes you learn that what you do in one house is not great for the next person. And, you know, Caroline will say if it has a smell, people can have a reaction to it. So then we learned even more from that. We need to have more talking to or whatever with our clients about all of the materials. It's the same with creating these healthy indoor spaces. And then you buy furniture from Joe's Schmo furniture supplier, and it's full of formaldehyde and stain resistance and whatever. So that's part of Pretty Good House talks about the big bad, right? So in our materials chapter, we talk about the stuff that across the board, you should probably just not do. And in a way that we hope is approachable, like if you're asking a material to do something that it doesn't seem like it should do, there's probably something in it that you don't want in your house. There are also some chemicals that have come up repeatedly that we're just like, this chemical compound is in this thing and you should probably not use it. But when we're talking about Pretty Good House, we try to make improvements until it financially doesn't make sense anymore. And that is different for different people. Then we try to look at first costs versus long-term costs, which I think is something people don't take into account. People talk to me all the time. They're like, I want a zero maintenance house, Emily. Not a thing. Sorry. Doesn't exist. Wish it did. That'd be great. But there are definitely materials that might cost a little bit more on day one, but don't need as much maintenance. So they'll cost you less money over the long term. So we have a tendency to talk about those things. I will often say the building envelope is mine and the interior layout is yours. Like interior walls, I don't have to live here. If your room needs to be a foot bigger, fine. But I've spent 20 years talking about hashing out wall sections with every building science person out there. Does it mean that we have all come up with the best answer? It's different on different projects. It depends. I say that a lot. People who are familiar with it know that that's my favorite answer. But essentially, it's my job to make sure I signed a thing when I became a licensed architect that said health, safety, and welfare. And I feel like understanding the enclosure is my job to make sure that it's healthy and safe for the occupants. And Steve Basic says this, we could build perfect buildings if they didn't have occupants. So like I also can't control what you're going to do in it. And this is something I learned from those energy consulting things that I did earlier, which is there are some things that we need to do for the structure regardless of who lives in it. And that's not always the easiest thing. And especially as we start making things more complicated, people don't necessarily know how to use it down the road. And so we need to have this balance between complicated things and actually providing healthy indoor environments for people. And that's interesting. Like, how do you do that? So there are things that we do for the building. There are things that we do for the occupants. You know, we still firmly believe that it has to be beautiful or people don't maintain it. So like sure, we could all live in Walmart, but people don't love that. They don't respond well to that. We have all these beautiful homes from the 1800s because they were gorgeous and they had craftsmanship and people really love that. And we have lots of things from like 2000 that people want to push down because they weren't built well. They didn't look like anything anybody responded well to. They were built from materials that just didn't really last. I have a thing about the real estate market where they're like, everybody needs at least 2,500 square feet and 3 bedrooms and 2 baths. And like the number of people I've talked to who are like, I don't want that, but it gets sold a lot. Yeah. And so they're like, well, clearly that's what we want because it gets sold a lot. And I'm like, no, people don't want to live in it. The things that aren't selling, 900 square foot, beautiful little capes in a fantastic neighborhood because you know what? People want connection, neighborhoods, that kind of stuff. Like there's a reason why some of those places are so expensive, which you can see where people have loved things and stayed in those neighborhoods because they've created community. I think a lot of people come to us and say, can you do a renovation on my house? It doesn't fit the needs of our family, but we love our neighborhood. We love our school district. Lloyd Alter writes about walkable cities or bikeable cities. People want that as well. So when is a pretty good house? Well, it depends on the person and what they want and how they want to live and what they might have reactions to and what their family looks like today and whether they're going to sell that house and downsize. Or, you know, we have people right now, and it's so sad, but they can't afford to leave their houses. Because where will they go?
No, it's so true. Even here where I'm at, like we don't love our house, but we have an incredibly low interest rate right now. We're in a community that we love. I have neighbors that I can call and be like 5 different people. I'm like, does anyone have a lemon? Does anyone have a cup of sugar? Like literally, you know, and, you know, we're just like, oh, give me your garage code, you know, in and out. Just that to me is so important. I get so scared to like move to the suburbs in an actual larger neighborhood where maybe my neighbors are more spread out. You know, maybe I would have the bigger dream house that I want, but will I have that community? And that just feels so important. So yeah, you have to really figure out what works for you and what do you need and be priorities off of that. And I love that response because a healthy home is so subjective. You know, maybe for a healthy home, it is just having a room with a sauna in it for somebody. And they're like, I love this. My house feels so healthy because I feel healthy when I'm in the sauna. And then maybe some person's like, no, you know, I am reacting to my paint, which I want to talk about paint with you now.
We're going to go down the paint rabbit hole.
Go down the paint rabbit hole. You know, it's always a common thing when people are like, I want you to help me build a healthy home. And it's like, okay, well, I have a lot of questions for you then. Like so many more follow-up questions because it's just health is not like a one size fits all.
Yeah, it's really not a one size fits all. And sometimes the answer is do nothing. And that doesn't feel like the right answer either. But at the Scale Up Carbon Down event, the opening speaker, he was lovely. He gets up and he goes, normally I do my doom and gloom slides, but I'm not going to do my doom and gloom slides. And then he proceeds to do like a half an hour of what I felt like was doom and gloom slides. And I thought, what are the doom and gloom slides? Because this is intense. But one of the things that he was really talking about with that is that every time we aim to be more efficient, we create and use more energy in the way to get to more efficiency, right? So when they started out, people were burning wood and then they were like, oh, but we found coal. So that's going to be more efficient. And what happened was they used just as much wood to prop up the mine shafts and openings to get the coal out of the ground that we were using as much wood and then we were using coal. Right. And then now we're like, you know, you're going in further. And then they used that coal because they were like, oh, this is terrible to start doing like fracking to get to oil and propane that we use. But we're still using as much coal to get to this, to get to the next thing. So like everything that we do to get more efficient, the thing is more efficient, but you're using all the old stuff in a different way to get to that efficiency. So it's also this reminder of we need to do things. And it doesn't mean that we shouldn't be doing them and we shouldn't be making progress and that we shouldn't be, you know, moving to electrification and that we shouldn't be doing solar energy and all of that. But it's not like a one-to-one, this is way more efficient. It's like, it's going to use this stuff to get to that stuff. You know, are we covering tracts and tracts of farmland to put up solar? Well, guess what? The sun doesn't shine at night. And so like, we still can't make all of our energy at that. And we're in a world where we're like, we want to try to reduce what we're using going and then make improvements. But at the same time, if you have to use so much upfront embodied carbon to reduce what you're using, do you ever get to the point where it's both doom and gloom and also not at the expense of progress, because we still have to make progress?
Yeah.
But realizing and kind of opening our eyes to the fact that it's not just making it better.
Yeah. This is a problem even more so in the mold space too, because when somebody has a water event in their home that leads to a mold exposure, it's, hey, rip it out. We have to get rid of it. We have to remove the contaminated materials. So people are just ripping everything out. It can't be cleaned. And then they're getting rid of not only that, but a lot of times they're getting rid of all their belongings and they're just putting that into a landfill. Maybe they're donating it. So it's like, oh man, if we could just build it healthy from the start, or at least consider moisture management and water control from the start, we could eliminate a lot of that too, because there's just like so many pieces at play that just end up causing so much waste. You know,
I love that you brought that up, because water is definitely the enemy of construction, and not only for those reasons, right? You talked about a water event that led to mold, but sometimes it's not a water event that leads to mold. And Christoph Irwin has talked about this too, is like, until you see the mold growing, you've already had a problem for a long time. And then Nikki Kruger will come on and she'll talk about it. And she's like, by the way, higher relative humidity makes our building materials off gas faster. So you have somebody who maybe had a mold activity, they left their house, they went to a different house, but maybe they live in a climate where they still have high humidity and they don't have a dehumidifier because that's not normal in their space. And maybe they don't have mold, but they're off-gassing their materials after they've had a mold exposure. So their immune system is already struggling. And now they don't see it because they don't have mold, but they do have a moisture issue. And that moisture issue is leading to health effects. And they're not the same thing. Maybe it won't happen for everybody, but it does happen to some people, like the whole Chinese drywall situation. There was a problem in the South because it was really humid. They know it went further than where they found it, but they couldn't find it because those places didn't have the humidity issues that they had in the South. The problem is it's getting hotter and more humid moving upwards. So are we going to start seeing that appear again, right? And we don't even know where it is. So I love that you brought up moisture, because, you know, even when I was doing energy audits, that was the very first thing. Like, do you have a source of moisture? And then when I am practicing in architecture and building science, I am the path of moisture. Can I drain? Can I dry? Right? Those are the options that you have. And one of the building materials, like we talked about for Pretty Good House, which is, are you asking it to do something that it shouldn't do? Like, I don't use moisture resistant drywall in my buildings because it's treated with a chemical to try not to grow mold. Well, guess what? That chemical off gases over time. It's worse for you than the actual, well, not the mold. And really, it's just a band-aid on a problem. Let's solve for, why is it growing mold in the first place? Why do we have moisture in this area? And some of that is like, oh, these bathroom fans are so loud and they never use it. Well, guess what? Let's make it so that you don't have a choice. Although I did a lot of energy engineering projects for a large scale company for several years in public housing projects. There's just a lot of different apartments and you have exposure to a lot of different people, and people are resourceful and they will figure out how to unwire things that they don't like. So whether you have a rental or whether you have a homeowner or whether you have a kid. One of my favorite stories, a friend of mine when we were living in New York, and his dad never knew this, but he was like, my dad was a contractor and he knew how to shut off the electric in my room because I'd be playing video games too late. But what he didn't realize was the outlet to my brother's room was on the same side, and I would just turn the outlet around from his room, which still had electricity, and I would still play my video games. People are resourceful. So you want to make it a little bit set it and forget it so they don't have to think about it. We need to think about sound is also such a critical piece to people's well-being. When you build high-performance houses that have a tendency to block out outside noise, every inside noise becomes louder. So you only don't insulate the plumbing for sound once in your career, because you find out the hard way that you can hear the toilet flush every time someone uses the bathroom. And that is like just water gushing down the wall. And It's just,
Yeah.
it's wild the things that you learn. And that's just kind of like a weird, inconvenient thing. But sound is something that people also relate to, and safety and pests. And I could just keep adding.
Yeah. I'm working with a client right now that's actually, it's always different priorities with everyone, as we talked about, but her priorities are electromagnetic radiation is top. And in tandem with that is sound. She's very sensitive to sound. So it's like going through a lot of different exercises of, okay, well, if we have an ERV, what is the vibration on that? Because she's very, very sensitive to the vibration. So we have to really plan for that. And normally we might not really even consider that, but we are all relating to that sound and vibration some way. It's just some that are more sensitive than others in it. But it's been a really interesting exercise going through like every piece of equipment, like trying to figure out how do we solve for the potential that this could vibrate or this could have a hum or a sound, because it really is important. And the more that you insulate from the outside, it does become louder on the inside. So
yeah, and it's crazy because things that you would never hear when you live in like a standard built house, because there's outside noise, and depending on where you live, it could be quite a lot of it. And then you just tuck everything in and it's really quiet. And you're like, then the refrigerator compressor kicking on is like the loudest noise. You're like, what is that noise? And you're like, oh yeah, I never would have heard this before. Or isolations for when we went from top loading washing machines to front loading washing machines or whatever. There was this time frame where people didn't realize the spin on those things, like the vibration. They would put them on a second floor and there would be so much noise vibrating through the whole house. And people like, wait, it sounds like the washing machine is coming through the house. And we could talk about the environmental aspects of people not cleaning their washing machines or draining their hot water tanks or changing the filters in their fridge. And it's a rabbit hole. For anybody listening, it doesn't mean that you shouldn't try. And that is why we created the Pretty Good House, because we want people to know that perfection shouldn't be the enemy of doing good things. And so just because I'm rattling off a lot of things, because the more I learn, the more I want to learn, does not mean that there aren't building professionals out there, and that sometimes you just do the things that make the most sense for you or in your area or what's available, and you think about those connections. And hopefully if you're working with somebody who's helping you to design or build it, you're just having really good conversations about it. Like the project that I was talking about earlier on with the multiple chemical sensitivities, the homeowner showed up with soy-based release agents for the concrete foundation that we were putting in to do their basement, and just talked to every subcontractor on the site that said, I realize that sometimes we may have to do stuff that has petroleum in it, but I want everybody on this job site to just take one extra second to think, am I doing the thing that's easy or am I doing the thing that's right for this project? And it wasn't like micromanaging subcontractors or telling you couldn't use your tools of the trades or whatever. It was just that extra second of thought to say, is there another thing here that would work that also doesn't blow the budget? Like for Living Building Challenge, you can get wiring that doesn't come in the plastic sheet, but it's so incredibly expensive and most people can't do that. So how do we cut down on wiring? But then if you're cutting down on wiring to get rid of petroleum, that's one thing. But then if you have a client who is concerned about EMF and radiation and Wi-Fi frequencies, you don't want to change to Wi-Fi frequencies to cut down on wiring, because then you're introducing another issue. Sometimes you have dumb systems and sometimes you have smart systems, depending on the client, the person, the reaction, the things that are, and like, what do we not know yet? So much of this technology, I know I'm older than I feel like I am a lot of times, but I love when something pops up on the internet and they're like, are you from the generation, like I'm older than Wi-Fi and the internet, which means it hasn't really been around that long, right? We haven't really been doing the things, and we already know that there's stuff in the built environment that we have been doing for a long time that maybe the healthcare industry has been treating people for, but we in the building industry haven't gotten the research from that to go, hey, I don't know how long it took them to figure out that asbestos was bad. It was a great building material. It did what it was supposed to do. This is not very good for you. Yeah. But here's my thing on spray foam. Yeah, some people say there's like no such thing as a bad material. There are probably some bad materials. Spray foam became a fix-all, which it is not. That was not what it was intended to do. The way that I approach or look at spray foam is a rigid object in a building that is not rigid. Have you ever had a building that doesn't have construction moisture, that doesn't dry out, that doesn't at least settle a little bit? And then what is the reality when it moves, cracks, shifts? And now we've opened up the possibility for voids in our structure that can allow moisture, which we already said is the enemy of our buildings, to potentially get into places that we don't know about. And sometimes we won't know about until it could be a massive issue. So that's the first thing, right?
Mm-hmm.
How does this material work with all of the other things? Which we talked about this. The building is a system. And how does this rigid piece of the system work with non-rigid pieces of the system? Okay, so now we've moved past the practical application of it. And we've talked about what is in it. If my installers have to wear a hazmat suit to install it, then they either need a degree in chemical engineering to make sure that this thing that they are installing is properly mixed, because that's usually where spray foam goes wrong. And if anybody wants to take a deep dive into that, go watch the BS and Beer with Henry Finelli talk about spray foam. And he wasn't even trying to convince people not to do it. He was just telling you all of the things about spray foam. So anyway, if you've got to wear a hazmat suit to put it on, first of all, contractors in my experience don't like to wear 4 or 5 pieces of PPE, right? You got goggles on, you're wearing a mask, you're wearing a Tyvek suit, whatever. The spray foam guys are probably getting better about it, but like they have to put a hazmat suit on to put it in. When we do things like that in a factory, there are so many regulations on what can go out into the environment, how it's the chemical mixture, are we watching it, it's in a contained thing. There's something smarter than a 2-part system and a weight machine, right? Like there's so much more in it in a lab or factory, similar with like packaged refrigerators versus heat pumps where people have to weigh. So that's my second thing, right? How does this thing work as part of the system? What am I asking my contractor to do to install this thing? That's part of the system. And then if you're really going down the rabbit hole, what is this thing made out of? How bad is this thing for the environment? And is there any other way to do it? Now, sometimes it is the best solution that we have available for the task at hand, right? Maine's got a lot of rubble stone foundations. If you want to insulate that, which is a great idea against moisture issues in the state of Maine, there's not another liquid applied material that can allow you to potentially properly encapsulate and insulate that space. In this instance, is it the right product? Maybe. But we're using a very small amount of it. We are not spray foaming our entire buildings. You have an existing structure that was built in the 1800s and there's just nothing else that you can do about it. Maybe, again, that is a place where you pick and choose. It also, at this point, has been dry for so long that hopefully it's not still moving and shifting, and if you're shoring it up. But anyway, there's some places where it can be, but as a rule of thumb, we're trying not to use it anywhere that we don't have to. So that helps us to protect the places where we do have to use this material, where it is the only solution. But I firmly believe that there is no scenario with new construction in which this is the only instance that you could do it. As a architect, I feel like that is a failure in our design end. If it is new construction, we haven't thought about it enough. And that's how I feel personally, and not everybody will feel that way about it, but I think Pretty Good House is pretty down in that spray foam rabbit hole.
And I pulled your book for anyone watching this on YouTube. We keep referencing Pretty Good House. This is Emily and her co-authors also wrote this book. I'll link it in the show notes for anyone who wants to read it and kind of go deeper into the Pretty Good House world. But what I'm seeing a lot of is like, there's just draftsmen who are designing a house. And then the builder's saying, nope, well, okay, you just give us the layout, let us know what you want. And then the builder's coming in and just doing whatever they want to make it work for code and inspections and whatnot. And so it's kind of like the wild, wild west in residential construction, which is why I always recommend all my clients have a licensed architect on their team. And you're working all over right now with Mottram Mains too.
Yeah.
If anyone needs an architect, Emily's working all over. You're licensed in many states, correct?
I'm licensed in many states. There's a couple that I probably would not get licensed in just for the length of time it takes to get licensure. Like in California, you have to do seismic testing and stuff like that. So if somebody reached out to me in California, I would definitely recommend somebody that I know in that area. Sometimes I do that anyway, depending on what your project is. As much as I would love to help everybody at every price point, at every instance, sometimes traveling for your projects isn't the best or easiest thing to do. We have a tendency, and what we really like to do is work with builders who ask the right questions. So we have a tendency to practice outside of our home environment with builders who really get it. And I appreciate that you encourage all of your clients to work with licensed architects. Not all licensed architects are created equal. And I do a lot of building science training for architects as well. If anybody has not looked up her courses, Christine Williamson also does a lot of building science training for architects. And one of the things that we have learned over time is that that's just not something that is necessarily taught. And sometimes we're starting from the beginning. Mike and I both belong to the Entre Architect group. And when we have time, we answer questions on there. Even people saying like using language that can be deceiving about like a vapor barrier is between the ground and the inside of your structure. We usually don't want vapor barriers as part of our wall system. We want vapor retarders. They should be vapor variable. Your structure should be able to dry. There's a lot more things that go into it. So we do a lot of building science training for architects. It's part of the reason why we wrote the Pretty Good House book, which is written in a way that homeowners can understand it and people who are getting into building science, and for people who want to practice like this, who asks me, how do you get your clients to buy into this? I want to say that let's change that narrative, because it's not about buying into building better. It's about doing better things. And they all want that. They just don't know what they're asking for. So you had asked me, how do people weed through what's bogus information out there, right? What's greenwashing and what's a reality? And so we tried to do some of that with the book, and that just said, look, we can't give you every answer to every question that you're ever going to have, because I don't know what that answer might be.
Yeah.
But we can give you a foundation, and we end every chapter with, have you thought about these things? Right? It's a dialogue about your structure. Have you thought about this? Here are things that you should think about. And then hopefully trying to connect people with the people out there in the industry who understand stuff. Like, I'm not the only one. There are so many cool people out there who are in this headspace, just like you, who are like, hey, there's something here and we need to know and we need to learn and we need to share this. That was always what our goal was to share, not gatekeep the things that we've learned, so that more people can be successful.
Yeah, absolutely. Yeah, it's such a great book. It's very easy to read for anybody. And I think you did such a good job at that. So I want to know, okay, let's maybe just start with this, Emily. Like, when you're thinking about paint, what are some of the things that you're thinking about before you even consider what kind of paint you're going to use for your walls?
Well, the first thing we're going to consider is, can we not paint this? So that is should we not paint this? Should there not be paint in this scenario? Should we be using a material that's going to require us to paint it? Because there was good paint, right? Turned out some of that paint was toxic. It stank.
Pretty good
right?
paint.
We moved to non-toxic paints, lower VOC paints, etc. Turns out that's just a different chemical compound that maybe has endocrine disruptors. Might not be better for you than the stuff that was stinky. It has other things in it. And this is where I work with people who are smarter than me. Work with a phenomenal chemical engineer who's like, this is what's actually in this. I'm like, great, because I can't read all of these chemical makeups of things. What does this mean for me, right? So then we start looking back at, what do they do to paint stuff before they had paint? Because the other thing is latex paint is the most common. And don't quote me on the exact percentage. People go and look it up. But something like 60% of the world's ocean plastic is paint. Like, it's a lot. Paint is what is getting into. It is changing the actual chemical compound of the ocean, because now there's a ton of paint in the ocean. And there's plastics and microorganisms growing on the paint. Anyway, we've taken petroleum and we've made this thing and we paint it on our walls. What about linseed paint? What about lime wash paint? Right? So we've been doing lime wash paint. Well, not everybody likes lime wash paint because it looks a little bit like a textured wall and it takes a little bit longer to do it and it has more labor involved in it. And so we're generally looking at, what is this thing, on the exterior of our buildings? Are we working with a naturally rot resistant, we're in Maine, so wood product that doesn't need to be painted? Like, can it be treated or dipped scratched or not painted? Or can you live with it turning to the silver gray color that wood looks like after it's been exposed to the sun? And can we do things so that you don't get the weird water staining patterns, or like some of it's shaded, some of it's not shaded, and everything looks different colors? So one, can we not paint it? Two, can we use a material that doesn't need to be painted? So like, what are our surface materials on the inside of the house, and do they need to be painted, and what kind of finish do they have on it? And can you live with something that could look different, right? Do we have colors? Can we use a, acrylic based natural wallpaper in this place, something that does breathe? We had someone ask us if they could swap out a vapor variable membrane for a vapor barrier paint on the inside. So that would technically meet code. And we researched it, and the perm rating of the vapor variable membranes is like 10, and the vapor barrier paint is like 0.3. And we're like, these two things, although they both technically meet code, are not doing the same thing. And like, it feels risky as we have more air conditioning to do that. And so our answer was like, although these two things both technically meet code, we don't want to do that. So like, you have this paint, and like, okay, do we have paint on a wall that is now stopping moisture flow? So that's the next thing I'm thinking about. Like, what is the paint doing as part of this wall system? And as I add this layer, should this layer be here? Is that okay for that layer to be here? And then the next thing I'm going to do is, it's not great to paint something with paint that is not going to stay stuck on to the thing it's painted onto. Right?
Yes.
So you go through all of this effort to paint something, and then the compound of the paint that we're using doesn't actually stick to it. So a lot of times this comes into play with like woodwork. Paint that sticks to wood is not the same thing as paint that sticks to drywall, or paint that sticks to other surface materials, cabinetry, MDF. And so paint, you have to start thinking about. And then, we always say, oh, okay, siding can be expensive. So we're going to do something that, and Ben has talked about this before. He's like, do I hate vinyl? He's like, maybe I don't hate vinyl as much as like, if I have something that needs to be painted every 5 years, I'm using more petroleum to paint it every 5 years than I would have to just have used this vinyl material before. So we also have to take into account, like, how frequently do you need to do that? And you know what a lot of people do? And there's this one girl on the internet, and I love her and everything that she does, but she paints her bathroom for every season. And I'm like, do you know how much paint is in this bathroom now? Right?
Yeah.
So when you're thinking about paint, it's like, what's in it? What's the chemical compound? How is the painter going to install it? Because if they're going to spray the walls, they often are going to use a paint thinner to make it thin enough to spray it on the walls. And that has other chemical components in it. Then how are they washing their brushes? Where is the paint going, right? And hence, this is where how the paint ends up. So like, paint isn't as simple as like, I hate this color. And like, sure, I have paint in my house. We all have paint in our house. But like, how could we think about whether or not we should use paint there, if it's the right solution, if long-term maintenance means it? And I don't know what it costs where you are, but if we have a house painted in Maine right now, it's like $40,000 just to paint the outside of the house. It's not even cheap to paint anymore. So check it out when Dan writes his article about it. I'm sure he will dive even deeper into paint from the contractor's perspective and from a pretty good house perspective of like, what is paint? Should we be using it? Where should we be using it? And like, how did we get here with paint?
Yeah. It's complicated. So I've been doing like lime wash projects in each of my house or each of my rooms of my house to just test it out and try it out. But in order to even lime wash a wall, you have to use a special lime wash primer. And some of the primers, they have proprietary materials. They have an odor. Like they don't tell you, you don't know really what the ingredients are. So you're compromising. You're using like, oh yeah, I'm using a mineral paint, but then I don't actually even know what's in the primer that's needed to get it on the wall. And then you have to use a sealer. Oftentimes, like if you're putting it in a bathroom or a place that is high traffic, you have to use a sealer on top of it. So I'm just kind of having these same dialogue in my own mind of like, well, lime wash is great. And I like that we are using a mineral-based paint, but
it's not the answer to all of our problems. Like, is it better time is money in construction and it takes longer, and not that we shouldn't be slowing down and spending the time, but like, could we be just looking at using something that doesn't require us to paint it? I don't know. It's the same with, technically you don't need to put plywood all over the exterior of your building. There's diagonal bracing, strapping, there's ways to do it, but we're conditioned to just do it that way. And so we do, right? So like, that's the easy way to do it. Is it the only way to do it?
Yeah.
No, but you could probably do that with every product, every building thing. It's amazing to me because, one, single family homes are going to be the most expensive way to provide housing across the board. Everything's new every time. It's just expensive. Yeah. There's no cost sharing to it at all. And then we have all of this stuff that we put in them to put them up. And we're like, yeah, well, this is just how we do it. But why? Why is this how we do it?
Yeah.
And could we be doing straw bale cubes as part of, it's such a big conversation in just the built environment and having to have a car and walkable cities and access to things and housing and wanting to have your own space, because that's the dream, right? We've only actually really had a lot of single family houses since the 40s. We didn't even talk about it, but like grass and lawn mowing,
don't even get me started. I mean, we're in Colorado and we're in a drought right now. People have these grass lawns. We're watering grass that it's not a climate that should even be growing grass.
Not to mention the thing that, just like the healthcare industry has become a multi-gazillion dollar industry on selling you like supplements and all these things that you should do, the grass industry is very similar. Right? You have to mow your grass every week.
Yeah.
Right? And nobody talked about the fact that grass is like a monocrop and like a super invasive one, right?
Yeah.
It has no beneficial anything to the things that we need that a lot of people want to get rid of, but like bees and insects and healthy planetary things.
Right.
I don't want dandelions in my grass. So then you're putting all kinds of crazy, like if you look at down in Florida in the Everglades where people put all kinds of stuff in their grass, and like now the Everglades have this whole water contamination, all of that, because first of all, half of Florida, I think, is like infill and was swamp before. And now the water table is at grade.
Yeah.
And then they all want to have these beautiful lawns and they don't want fire ants and other stuff in it. So they treat it with stuff, which just means it gets in the water.
And the spraying and the pesticides, like my mom owns a condo in Fort Lauderdale, so we go down there often, and there's little flags everywhere in the grass that just say like, keep pets off grass, it's been sprayed. And it's like, how does
like,
this
if
make
your
any
pet can't walk in it, then it's like getting into the water source, which means that we should probably also not to be drinking it.
Right.
And then we use all this stuff to treat the water that comes back to us, like the whole fluoride in your water system and chlorine. And it was kind of eye-opening to me because I like to hang out with people who are smarter than me. So it's always eye-opening when somebody presents all kinds of things, and they were talking about, like, we know when we have a well, we get our well water tested because, like, hey, what's in this well water? But it turns out even when you're on city water, you should have your water tested because the first person from the water treatment plant does not have the same water as the person that is all the way at the other end. And that became really apparent to my husband and I when we moved to the house that we live in now. And we put on a micron filter as soon as we moved in. Like, let's just do a whole house water filter to start because we know we're on town water or whatever, but everybody needs a filter. So we put a filter on the water system and it filled up with copper, absolutely full of copper. So I called the water department and I was like, hey, I have copper in my water. And she's like, well, how do you know it's copper? Is it slimy? And I was like, it's not slimy. This is what I do. I didn't have it tested, but it's quite literally just green copper flakes that are like metal when I dump the thing out. Like, I was like, I have a 5-micron filter. She's like, oh, I don't know anybody that has that low of a filter. I'm like, you can buy this at Lowe's. Like, it's just like something off the shelf. And she's like, no, it must be your copper water lines in your house. Right? I'm like, this is like right after my meter. It doesn't even run in my house. It's like the first point for when it comes in. And once you know, I think in a week or two after I called her about this, the water main in my neighborhood broke.
Oh, wow.
Tell me again, you don't have a problem with your water pipes?
Yeah.
Like just
That's crazy.
gushing
Oh
in
my
the street.
gosh. That's the other thing too. The city will do a water quality report and a lot of people will just base their, filters off that city water quality report, but there's so much that can happen like
Right. You have no idea
throughout.
what it can get exposed to between that
Exactly.
point where they tested it and sent it out and where you are. Just like, the water main broke here where we are. Are there
Mhm.
places where there's contaminants or something from capped places along this? Like, it's not a perfect system from the water treatment plant to
Mhm.
your house. There's so
Yeah.
many things that can happen. And, there's lots of old cities in the country who, like, they're getting to the point where they need to replace the systems that they have.
Mhm. Yeah.
We did a big energy engineering project in the city of Portland, and I think we put in like 1,000 toilets, maybe low flow toilets, and saved $18 million. Like they paid for themselves in the first year because
Wow.
the city knew they needed to replace their water main, so water rates got higher, and so we just used less water. It's amazing how we don't think about the things that are sort of, here's another rabbit hole. Jeez. With this
I
book
love
called
it.
Garbology. I think it was written more than a decade ago. And this guy was like an archivist. He would go to the landfills. And so he did like a core drill in the landfill and he found a hot dog bun from 40 years before, right? Because nobody wants to smell the landfill. So they put stuff over top of it, which just basically makes it like a fossilized landfill. Just because it's
Wow.
biodegradable doesn't mean that it's going to biodegrade in a particular environment. But as part of that book, what he talked about was we're all hoarders if you weren't allowed to send your trash to the landfill, right? So we all think like, oh my gosh, these hoarding properties or whatever. And literally that is mostly just a reality of our everyday life. So if you didn't think about what you sent to the landfill, you would have to live with all of that
Oh
stuff.
my gosh.
And if you, like, what you donate, what you send to the landfill would all just still be in your space. How much would you have? Right? Mind blown. I was like, that is
Oh boy.
shocking.
I
Yeah.
am having an existential crisis. That's such a good perspective and way of looking at it because
Yeah.
one of the things I like to say is like the best filter you can get for your whole house is your front door. What are you actually bringing in it? Like
Yeah.
the little stuff. Like I think about the conferences, all these different conferences we go to. We have bags, we have the pamphlets, the books, all the gizmos, the gadgets, the squeezy squishy toys they give you. Like, are you taking it? And if you take it, what are you doing with it? And then where's it
Yeah.
going?
If you ever see me walking around at any of those conferences, you'll notice I am always sans a bag. As an architect, product manufacturers are always want to be like, can I send literature to your office? And I'm like, mm-mm.
Please no.
One, because my first job when I started working for an architect was to go through her library of stuff. She had code books from like 2 decades before. That's a code book, which is realistically you actually need. But then there was just like product literature. Like, these people don't even make this product anymore. So I'm always like, please feel free to send me digitally whatever you want to send me. And if I need to order a sample for a client so that we can show that to them, that's a thing. But don't just send me stuff. We're not a stuff office. I'm not saying that we don't print, like I have a set of drawings that's printed behind me. This is the final construction documents that I printed for the client. But we try not to print like every time that we have a set of drawings, and we're not a paper-free office. I'm not sure that's possible in our industry, but like we have iPads. We do a lot of stuff digitally. We take that with us when we go to meetings. We try not to print like, here's the set of drawings again. And it's like, I've given you a set of existing conditions every time we've come, and you have 45 sets of existing, like trying to think about how can we be more creative with the stuff. And so like as a product manufacturer, please don't send me your stuff. And when I go to these conferences, occasionally I will tell you construction pencils are nice. I like construction pencils because we're handy and we're doing our own construction project right now. And you never have a construction. Tape measures are also nice. I'm not sure you can ever have too many tape measures. I think we have 12 tape measures and you can never find one when you need it. So like they'll probably never get thrown out. They'll just live in all of the nooks and crannies of our house. It's like there's a tape measure, but never where you need one.
No.
But like, I don't want the reusable bag and the pounds of literature and the stress ball thing. I don't want any of those things.
I couldn't agree more because those are like inevitably going to be in a landfill at some point.
Absolutely.
Like, even if you think you want it, you're like, oh, cool, this is cool, I'll take it. And then next thing you know, it's still in the bag and you're just taking the bag directly to the garbage or donating it or whatever.
Water bottles. I don't need 45 water bottles.
Those are not allowed in our house. My husband will murder me if I bring another water bottle because they just always end up going to donation. It's like, how many more water bottles and coffee mugs do we need? So I completely agree. But that's wild. Garbology. That's
and like I don't know if he's written like an updated version of it, but like it blew my mind just thinking about so much of garbage waste is food waste and we should be composting. I lucked out where I live. There is a company that does composting. So essentially we put it in a 5-gallon bucket. They turn it into compost and you can either get compost back in your 5-gallon bucket, or if you don't want the compost because maybe you don't have gardens or you can't use it, they donate it to the schools. So they partnered with a local farmer to create compost. People don't have to do the whole you're gagging, it's gross, you have to stir it into whatever. Like I understand that composting is not always easy for everybody to do, but it is a massive amount of actual waste that goes to the landfill is food waste. That's one of the best things that you can do is compost. And so like that book taught me about like best practices like and that we used to do that. We used to separate out glass and metal, compost, and then things that went to the landfill. And then we stopped doing that when there wasn't any repercussions for what you threw out. You just put it in a bag and it went somewhere else. Out of sight, out of mind. And then similarly to a discussion we were having earlier, is like efficiency uses every more thing. Like we're making more efficient appliances, but these more efficient appliances now don't last as long. So we have now created a waste stream. Like I think right now the lifespan of an appliance is like 4 years.
Yeah.
Like when I was growing up, I had family members that had freezers that were 30 years old. Yes, they used more energy. But if you think about what it took to make a newer, more efficient thing that then had to be replaced every 4 years, it probably was more efficient to keep the thing that was 30 years old. Like, wild.
You're on point. Everything we've ever owned has broken in like 5 years. And I'm like, this is insane. Do you have an appliance brand that you're like, no, but this is tried and true. We only use these because they last forever?
No, not necessarily. Like it really depends, you know, on sort of the heat pump hot water tank debate. We've tried every brand of different heat pump hot water tanks, and circa certain eras, some of them are just bad and have bad compressors. It's like, oh, we thought this was great. And then they had a run. And we have a tendency to say you shouldn't buy appliances that are made by people who don't make appliances. So like some appliance brands are actually like electronics brands. There's a little bit to that. It's hard to say. Sometimes a cheap appliance by a reputable brand might be a little bit more energy intensive, but could be better than the other thing that I think people don't take into account, which comes way back to water again, which is you live in Colorado, so dry. And if you don't have enough humidity inside your house in Colorado, you can actually electronically shock your appliances. So you can kill your appliances because you don't have enough humidity in your house.
Oh, wow. Interesting. I haven't heard of that.
Oh, yeah. That one's fun. Doesn't necessarily kill everything, but it kills the electronics on it, which sometimes means that it doesn't work anymore.
We actually had like a fuse blow up on our range. It was kind of odd. We were like, that's interesting. Would that be an example of
maybe
this?
It could have been like it was really dry and one of you in your fuzzy socks walked up to it and you were like, ow, it zapped me, except for like, did you actually at that point give it electric shock?
Wow.
Like it's wild, the things. So we both need to humidify in some environments and sometimes of the year to have enough moisture.
Yeah.
Like anything less than 30% is tough and it's nosebleed dry, but you can also have like static shock. And we're like, oh, that's inconvenient or it hurts or whatever. So, you know, we fried our refrigerator. Did it still stay cold? Yes. Did the electronics work? Nope. I feel like you couldn't get ice out of it. You couldn't do any of the things. And now everything is more electronic and it doesn't work. And usually that's the part that fails. It's not usually the components that are part of it. It's the control that tells the components what to do.
Yeah.
So.
Oh, interesting. I'm sure there's probably some impact on having like synthetic materials too. Like, not that you would have carpet in a kitchen, for instance, but like using LVT or things that are just more synthetic materials would add to that static pressure and electric shock, like the
Yeah.
dryness. Yeah, that's
Yeah.
interesting.
The dryness, is your house actually grounded, right? So there's some
Yeah.
like old houses with kind of questionable electricity. Like there are
Mhm.
lots of things that kind of roll into that.
Oh my gosh, Emily, this has been so amazing. Thank you so much for taking the time. Is there anything that you've been working through as a way to better yourself, to evolve your soul? Just anything that you want to leave as a little nugget of wisdom for people?
I am always trying to figure out, and Christoph said it, not do things better, but do better things. And so really, I appreciated the Scale Up Carbon Down event that I was just at recently, which really put on to our heart that in some ways we need to be going backwards, not forwards in some of the things that we're doing, which I think that as we are always working towards, more efficiency, more, and nothing wrong with that, we stop to take a moment to pause. And I think that's true in life in general, is like stop and smell the flowers. That makes us more creative people, but also stop and go, just because we've been doing this for like a long time, it doesn't mean it's necessarily the thing that we should be doing. And so I encourage everybody to just take a deep breath and a pause. And we live in a fast-paced, consumable world.
Mhm.
And, even the things that we consume, like I love that we just talked for an hour and a half. That was awesome to me because sometimes it's like I watch this 30-second video. That's the like track that we get on, or
Yeah.
I'm in my email all day and I don't get a large chunk of time. So I try to schedule block my time so that I can have creative thought and creative process and really work through. And so let's just encourage people to remember to do the things that are important but not urgent.
I love that. And you're so right. I feel like we get so caught up. I've even found myself scrolling through something and being like, up next. And like just attention span is so short.
Yeah.
And yeah, just like take a breath, take a pause, slow down, and do what feels important, not urgent. I love that.
Yeah. There'll never be a right answer. We'll always be striving to learn more, do more, make it better, do all of those things. I feel like a lot of us who care so much about this industry and about people and about their lives are like, don't know the word no or pause, or you want to have an impact and share your knowledge. And sometimes it's like, whew, okay, we've been at this.
Yeah. Like, how much have you done? Like, wanting to do so many things, especially you. Like, I feel like you do so many things. Don't you wear so many hats? Let's just talk about that because I want people to know, like, where can they find you? What are you doing? How are you teaching? You don't just own an architecture firm. You're always presenting and teaching. And so share with everyone what all you do
Share
and
with
where
the
they can
class.
find you.
I appreciate that. We do own an architecture practice that's primarily based in Maine, Mottram and Maine's. So you can find Mike and I there. We also do the BS and Beer Show the first Thursday of every month, where we try to bring building science knowledge to the community and hope that it's fun and informative. We've had a lot of great people come on and talk about all kinds of different things. We actually just had Hector and Marcella from Efficient Build on talking about building in wildfire-prone areas. And so that's a passion project that started at a local building science discussion group here in Maine, where we got together once a month as professionals and we talked about what does it mean to build better things in the state of Maine, which is actually what started Pretty Good House. So Pretty Good House has a website and there's a book that's available. It's got a long life ahead of it as we continue to do more things with it. Our friend, if you're listening and you are an instructor at either a high school or college trade program, our friend Matt Bloomquist just wrote a curriculum based on Pretty Good House, which is what he's been teaching with his students for the last 3 home builds over the last 7 years in Taylorville, Illinois. So he's written a curriculum for other teachers who want to involve that as part of the Pretty Good House process. And I have a podcast called E3 Energy and Efficiency with Emily, which talks about architecture, building science, and being a female entrepreneur, which always just trying to give a big shout out to everyone who is non-traditional, who wants to jump into any kind of STEM program, just being out there to say, there are women in this industry doing really awesome things. There are other people who are like you in this industry. So I like to highlight what other cool people are doing out there. I often am out at construction instruction in Denver teaching advanced building science classes with their group. So I will be there in July, which you may not be listening to this before then, but I think I'll be back out in October. But they do classes all year long, and I'm not the only instructor. Lots of great people. Travis has been out there. Ben's been out. Lots of great instructors. But there are all kinds of cool people doing cool things. If you find us on Instagram, LinkedIn, and Facebook through Mottram and Mains, that'll list usually a lot of the places where I'll be training and teaching. And if you're in Maine and part of the community college system, we'll be starting our sustainable design class up again in August, I think. So
wow,
I do a lot of things. So I need to take my own advice.
Exactly. Always easier said than done. Thank you, Emily. This is so amazing. We will link everything in the show notes that we talked about today. So it's really easy for anyone who's listening here. But thank you so much, Emily.
Thank you for having me.
Thanks so much for tuning in to the Awakening Spaces podcast. If you're ready to take what you've learned and start applying it to your own home, then there's a few ways that we can support you. On our website, you can find a collection of free and paid guides and courses that will walk you through everything from designing a healthy home to choosing safe materials and reducing mold, chemical, and EMF exposure. And if you're looking for more personalized guidance, then we also offer one-on-one consulting and design support, where we act as your owner's representative to help you plan, manage, and execute your new build or renovation project with confidence. You can explore all of these offerings on our website at awakeningspaces.com. And if this podcast has helped you in any way, we would be so incredibly grateful if you would like, subscribe, and share this podcast so that it can reach more people. Until next time, thank you so much for listening and being here and stepping into what it means to be an awakened homeowner.